Hello, dear students. Hope you are fine and your families safe. And today we shall continue our studies in Statistics 1, Lecture 4. At the last lecture, it was in the central measurements of data, and the last point in this lecture was about squeeze and kurtosis. Squeeze in Arabic means التواء, and kurtosis means تفرطح. So we know that the data or the observation may be frequency distributed in normal or standard curve, like that. It's normal frequency distribution curve, where the mean equal the median equal the mode. This curve or normal distribution curve has a bell-shaped شكل الجرس, and you will find that the observation distributed normally, and you will find half of the data toward right and half of the observation or data toward left. This observation may be skewed toward left. Skewed toward left, that means we have a tail where more data lies, while the other tail has no data. So in this case, this is skewed distribution curve toward left. You will find the mean and the median and the mode, where the more frequent points are. In other case, data may be skewed to the right, so you will find more items of data or observation lies towards the right. We have a tail towards the right, and you will find the mode, then the median, and the mean where the most data is in. This is called squeeze, التواء. Squeeze in many cases an observed frequency distribution will depart obviously from the normality. The data will depart than the normality. It is useful to measure the nature and the amount of this departure. The nature means it's data towards the right or the left, right or the left. That's the nature. The amount of this departure could be known by the median and the mode. The other character which may show a departure of data called kurtosis, التفرطح. It's the other type of departure from normality. That is the normal distribution curve. Normal distribution curve, bell-shaped curve. This shape may have a platycortic curve. Platy منبطح. Platycortic curve like that, where the fewer items are at the mean area and at the tails also, and the most items or observation found in the intermediate region. Most observation found in the intermediate region, while at the mean area and at the tails you will find a fewer number of observations. This is called platycortic curve. Curve منبطح in Arabic. The other type, which is leptocortic curve. Leptocortic curve. In this case, more items near the mean. More items near the mean and at the tails, with fewer items in the intermediate area. It's vice versa the platycortic curve, where in leptocortic curve you will find more data near the mean and at the tails. That makes the curve leptocortic محدب وبارز للخارج in Arabic. This nature of curves, which is leptocortic or normal or platycortic, gives us an idea about the nature of data. The other point is the measures of dispersion. مقاييس التشتت. Measure of dispersion of observations or data. And we can measure the dispersion of this data around the mean by many methods. مقياس تشتت الداتا حول المتوسط. We may use the range, المدى. The range, it's one method of measuring the dispersion of data. انتشار أو توزع الداتا. The other is mean deviation. Mean deviation or اللي هو الانحراف المتوسط or the standard deviation الانحراف القياسي. The standard deviation. We took an idea about standard deviation with Dr. Fatma. The variance التباين. The variance التباين. The standard error الخطأ المعياري أو القياسي. The standard error الخطأ القياسي. The coefficient of variability. The coefficient of variability معامل الاختلاف. These 6 measurements we can use it to measure the dispersion of observation around its mean, either in sampling or in a population. First, the range. The range is the simplest measure of variation. The range is the simplest measure of variation. The range could be identified or defined by it is the difference between the largest and the smallest measurements in data. The largest and the smallest, the difference between it. For example, the range for the measurements 10, 12, 15, 18, and 20 is 20 the largest minus 10 the lowest equal 10. That's the range. The range is 10. The difference between the highest and the smallest observations of data. Another example, the range of measurements of 2, 8, 15, 22, and 28 is 28 minus 2 equal 26. That's the range of this data. So we can use the range for measuring variation. Look to the data 10, 12, 15, 18, 20. The other is 2, 8, 15, 22, and 28. Which samples are more varied? 2, 8, 15, 20, 28, or 10, 20, 12, 15, 18, and 20. It is the second sample where the range is higher than the range of the first one. So the measurements in the second set, these measurements 2, 8, 15, 22, and 28, quite clearly exhibit greater variation than those of the first set 10, 12, 15, 15, and 20 in the first set, and this reflects itself in much greater range. If we have greater range, it means we have greater variation. Okay, again, the range is the way to measure the variation. التباين. The range identified by is the difference between the largest and the smallest measurements. For example, if we have data 10, 12, 15, 18, and 20, the range of these measurements is 20, the largest, minus 10, the lowest, equal 10. That's the range. In this case, the other example, the data is 2, 8, 15, 22, and 28. And the range is 28, the largest measurements, minus the lowest one, equal 26. Here we have to compare between these two sets of measurements. Which one is more varied? The variation of the second set of data, 2, 8, 15, 22, and 28, is more variation than this data, which is reflects on its range. Here the range is higher than the range of the first set. But using the range for measuring variation has two disadvantages. First, for large sample, it is unstable descriptive measure. If we have a large sample, it's difficult to use the range for measuring variation. Consequently, it should be used with small samples, only 10 or less. If we have a small sample, we can do a comparison between this sample by range. As the first disadvantage, it is not, we can't use it by measuring the large sample variation. The second reason, the range is not independent of sample size. It's not independent, not dependent, independent of sample size, except under special conditions or circumstances. The range is not independent of sample size, so we couldn't use it in measuring variation for large sample. The other measure for mean dispersion is the mean deviation. mean deviation MD الانحراف المعياري mean deviation انحراف المتوسط الانحراف المتوسط. It could be defined as mean deviation is the general arithmetic mean of the absolute deviations from the arithmetic mean. The general arithmetic mean of the absolute deviations from the arithmetic mean. Sample arithmetic mean, of course. For example, consider the following measurements. Sample A 8, 8, 8, 8, 8, and the mean is 8. It's a sample. Sample B 1, 4, 7, 10, 13, and the mean X bar is 7. The mean, which algebraic X bar is 7. Sample C 1, 5, 20, 25, 29, and the X bar or the mean is 16. The deviations of these observations from mean is 0, 0, 0, 0, 0. 8 deviation الانحراف عن المتوسط. 8 minus 8 equals 0. 8 minus 8 equals 0. 8, 0, 8, 0, 8, 0. And the deviation in case 2 in sample B will be minus 6, minus 3, 0, plus 3, plus 6. In the third case, sample C, it will be minus 15, minus 11, plus 4, plus 9, plus 13. That's the mean deviations of the readings of sample A, sample B, sample C. We have to know that the measurements in sample A are less variable than the sample B. 8, 8, 8, 8. There is no variation between these measurements. All are 8, while in sample B 1, 4, 7, 10, 13. Sample A 0 variation, sample B less variation, and sample C is more variable also by its readings. Look to the mean variation of these samples. Numbers suggested that variation increase the departure of the observation from their sample mean increase. Again, from these samples we can find that as variation increase, the departure of the observation from the sample mean increased. As the variation increase, here the variation is 0. Here we have more variable, and here we have more than B variable of data. Zero, 4, 3, 9, 6, 13. So sample C is more variable. How we can calculate the mean deviation? The mean deviation, the general arithmetic mean of the absolute deviation from the arithmetic mean. How? Mean deviation equal summation. These two bars means ignore the algebraic sign. These two bars means do the deviation with ignoring the sign, algebraic sign, over n, which is the number of observations. In first case it was 0. In second case, if we are looking to the samples deviation, it was 63036 over 5. It means 18 over 5. It means 3.6. In case of sample C, it will be 15, 11, 4, 9, 13 over 5. It would be 52 over 5. It means 10.4. That means that the mean deviation is the summation with ignoring the algebraic sign between the observation and its X bar upon number of observation. That's the mean deviation. We have to go back to this slide. That's the deviation. If we ignore the arithmetic or the algebraic signs and get the summation upon the number of the observation, we will got the mean deviation. انحراف المتوسط. That's the mean deviation. We shall got an exercise, but the number is clear. The deviations in sample A was 0. The deviation after ignoring the sign is 63036. Summation of this observation upon number of the observation 5, it is 18 upon 5 is 3.6. The mean deviation of the sample 3 was 15, 11, 4, 9, 13 upon 5, it is 52 upon 5, 10.4. So the mean deviation of sample A is 0. The mean deviation of sample B is 3.6, and the mean deviation of sample C is 10.4. And as we know, or as I told you, or as you saw that the variation in sample 1 or sample A was no variation. 5 numbers 8, 8, 8, 8, 8, 8. In the second one, which is more variable, it was 3.6. The third one, which is more variable than B or var, it was 10.4. So we can use the mean deviation for measuring the variation in data, measuring the dispersion around the mean, the variation of data. As we have high mean deviation, that means that the data is more variable. Thank you for listening this lecture. I will send it immediately to you on the YouTube and the model of the university. You will find the link on the group WhatsApp, and you will find this lecture on the Moodle of the HU University, and you will find it also on the YouTube channel. Bye bye.